2 and 1. So there's nothing really like being able to see a ton of examples. So here I present to you numerous probability examples. These are kind of the basics, but it's nice to see them and the variations. So let's get started. I'm going to try to knock off 15 examples as I guess as quickly as I can, but also of course try to explain them. Okay, so let's go. Question 1. What is the probability of flipping a coin and landing on heads? So this is probably as simple as it gets. So when you are flipping coins, you really have just two options, assuming that you have a fair coin: heads and tails. And both of them have a 50% chance. So if you want to get just the probability of heads, that will be 50%. That is it. Question 2. What is the probability of flipping a coin 2 times and landing 2 tails? So in this case, you have now 2 flips of a coin. So you can do your tree diagrams if you like. So heads, tails, repeat them, rinse and repeat. So duplicate right there, duplicate right here. That's what you will have. Those are 2 different flips of coins. Now here they are saying that we want to be able to have tails and tails. So that is your path. Now these 2, so you have a 50% chance of landing on tails on the first go, and then another 50% chance landing on tails again. So what you will have is 1/2 multiplied by 1/2, which is simply 1/4. So that is the probability of flipping a coin 2 times and landing both times on tails. So that's how you would do it. Question number 3. What is the probability of flipping a coin 3 times and landing at least 1 heads? All right, so this is question number 3. So probability, okay, 3 times and at least 1 heads. All right, so for this one, whenever I do see this at least 1, then I like to use complements. So what I'm going to do is I'm going to take the probability, so 1 minus the probability that all 3 are tails. Now, if this happens, if all 3 are tails, then obviously I got no heads. So that means 1 minus that probability will give me the probability of at least 1 heads in your tosses. And that would mean, so if you would be drawing these tree diagrams again, it would be basically every single combination except, okay, the one that has all tails. So for this to get 3 tails, so notice that's 1/2 multiplied by 1/2 multiplied by 1/2. Why? Because the probability of drawing a tails on the first flip is 1/2. The probability of the second one is also 1/2, and then this is also 1/2. So this becomes 1/8. So that means it's 1 minus 1/8. So the probability is 7/8. You can change that to a percent if you like. That is question 3. Question number 4. What is the probability of flipping a coin 3 times and landing at least 2 tails? All right, so something similar. So 3 times. So now probability of 3 times, once again, at least 2 tails. 2 tails. So this one, it does say at least, but now it says at least 2 tails, not just 1. So this one, that I can approach this, so how can this happen? So 3 flips, so you're either going to get, so let's say 2 tails, so you get either this. Now how can this happen? This can happen in this way, it can happen in this way, so you can check the different combinations that you have. It can happen in this way. So those are all the different ones that you get at least 2 tails, or sorry, at least 2 tails. And then of course the last one is this one. So you have tail, tail, and tail. So all of these give you the probability, okay, of receiving at least 2 tails. Anything else is going to be either 1 tail or no tails at all. So within here, so notice that for all of these, so the probability of doing this is 1/2 times 1/2 times 1/2. Now the probability of this is exactly the same. The probability of this and probability of this is exactly the same. So all of these are basically 1/8, and there's 4 of them. So this is 4 times 1/8, which is equal to 4/8. So it is 50% chance that you will have at least 2 tails. That's what you have there. Okay, question number 5. What is the probability of flipping a coin 3 times and seeing at least 1 head or 1 tails? All right, so seeing at least 1 head or 1 tails. So now this one is 100%. So now let's think about that. Okay, so here we have the probability, so this is number 5, probability of seeing at least 1 head, so at least 1 head or 1 tails. So what's the probability of those? Well, the probability, so this is because it's union, so this is probability of at least, okay, 1 head plus the probability of at least 1 tails. And of course, you know, the intersection of the two we would be subtracting here. But, okay, if it says you're going to see at least 1 heads or you're going to see at least 1 tails, that happens in all the possibilities, right? So, because what are all the possibilities? So you can get, you know, a heads, and a heads. You can get a heads, and a tails. Okay, so that's one of the items, and then you can go along the branches there if you're doing a tree diagram. Okay, so notice no matter what you do on any flip, you're going to get heads or tails. And of course you can now continue this. You can get heads, tails, heads, heads, tails, tails. So notice you're always going to get a heads or a tails, and then you can continue this down all the way down to tails. So the probability is 100% for this one. That's what this would be. Because if you're going to be flipping a coin, and here, okay, it says, now it doesn't really matter. Okay, so here, what's the probability of seeing at least 1 head or 1 tails? You know, even after 1 flip, you're going to see already a heads or a tail, right? So that means it's going to be 100%. So that's question number 5. Question number 6. What is the probability of drawing a card and seeing a 2 or a 3? So if you're going to be drawing cards, so we're going to assume that it's a regular standard deck. So we have 52 within the deck. So how many 2s are there? Well, there are 4 2s in a deck. And how many 3s are there? Well, there's 4 3s in a deck. So notice, because it says or right there, so either or, well, in total, okay, how many of those cards do we have? We have 4 2s and we have 4 3s. So our probability of a 2 or a 3 is simply, okay, the probability of the addition of the 2, which is going to be 8. So there's 8 possibilities out of the 52 cards. And you can reduce that to lowest terms if you like, or change it to percent. So that's how we would do this. And this is because we have 4 of these and we have 4 of these. So that is the 8. And then we have 52 cards in total. Question 7. What is the probability of drawing a card and seeing a non-face card? Non-face card. Well, what are the face cards? So the face cards are either jacks, queens, or kings. So how many jacks are there? There's 4 jacks. How many queens are there? There's 4 queens. And then there's 4 kings. So in total, 12 cards that are face cards. Now here it says non-face cards. So really what they're asking us about for question number 7 is what is the probability of face, okay, which is the complement of that, because we don't want to see a face card. So that just simply means 1 minus, so there's 12 out of 52, again, jacks, queens, and kings. So if you do this, okay, so if you take away 12, so that's going to be 40 out of the 52 cards are non-face cards, and that is the probability. Again, you can reduce that or change it into percent if you like. So that's that. Question 8, what is the probability of drawing a card and not seeing an ace? Notice, not seeing an ace. Well, how many aces are there? There are 4 aces, right? So there's 4 aces. Well, we don't want to see an ace, so we have the following: 1 minus 4 over 52, which just simply means 48 out of 52 is going to be the probability of not seeing an ace. Again, you can change that to percent if you like, or reduce it. So that's question 8. Question 9, what is the probability of flipping a coin 2 times and seeing both heads, then drawing a card and seeing a face card? So this is basically just compounded probability. So there's 2 things happening. You have flipping a coin 2 times, seeing both heads. So we would have that. So that's the probability of heads and heads. Now, what's the probability of heads and heads? Well, the probability of just heads is 1/2. Probability of seeing another heads is again 1/2. So that means this is 1/4. Okay, so that is the probability of seeing both heads. Now then it says, now we're going to draw cards. And now we're going to draw cards and we're going to see a face card. Well, what's the probability of seeing a face card? Well, the probability of seeing a face card, there are 3 face cards, jacks, queens, kings. There's 4 of each of them. So that means 3 times 4, which is 12. So 12 out of 52. So that's what we have. So probability of face card. So now let's actually reduce this. All right. So now 12 and 52, so it's divisible by 3. So here, this is going to be, actually it's not divisible by 3, it's divisible by 4. This is going to be 3, okay, over 13. Now, the probability of heads and, okay, then seeing a face card, right? So this is just equal to the probability of heads. This is independent events multiplied by probability of seeing a face card. So what does this equal? 1/4 multiplied by 3/13. And this is 3, and then 4 times 13 is 52, and that's your answer. That's what you would have. You can change that if you like to percent. So that was question 9. Question 10, what is the probability of drawing 2 cards and obtaining 2 jacks in a row with replacement? So we're replacing cards here. Okay, well, drawing a card. Okay, so here's drawing 1 card, and then we're going to draw another card. Now, when it says with replacement, that means after we draw the card, we put it back into the deck. So, well, what's the probability of drawing a jack? Well, the probability of drawing a jack, there's 4 jacks in a deck. So it's going to be 4 out of 52, or just simply 1 out of 13. Now, if we put the card back in, we still have 52 cards, and we still have 4 jacks. Now, we're going to, assuming that we're going to probably shuffle this again. You know, you're not putting it back on top, because then there's, 100% probability. So in this case, we have another 4/3, so this is going to be 1/13. So that's the probability. Now, what do? Well, we multiply them. They're independent of each other in this case. So we have 1 and then 13 squared, right, which is 169. So the probability of drawing a jack and then a jack again is actually very low. Okay, so that's what you would see here. And then you can convert it to percent if you like, and you'll see that it's a very tiny percent. So that is question 10. Question 11. What is the probability of drawing 2 cards and obtaining 2 jacks in a row? No replacement. So how does this differ? When we see no replacement, that means we're not putting back the card. So this is basically a conditional probability. You know, when we take out our first card, so a jack, it's going to be probability if there's 4 jacks and 52, so that's 1 out of 13. But now we do not put the jack back in. So there's less jacks, right? So this is basically now a conditional probability where we have taken one of the jacks out. Well, how many jacks are left now? There's only 3 jacks left, but there's also 51 cards, 1 less card than we took away. So this, now all of a sudden, so as you can see, this is going to be 1 times 3, which is 13, and then 13 times 51, which is going to give you your probability. Now you can multiply, find out whatever you need, but that's how you do it with no replacement. All right, so that's question number 11. Next question. A study of 500 participants has shown that there is a 15% chance of selecting a participant who likes probability. Yes. Okay, it's not very high, I guess. Not a lot of people like probability. What are the chances that from the group you pick someone who doesn't like probability, and then that the person rolls a die and sees a number equal or less than 5? All right, so for this, so here it says we have probability. Now, okay, it says that we want to have, so this is, that likes probability. Okay, but we want the complement of that because they are saying that you're going to be choosing a person that doesn't like probability, does not like probability. Now, then they're going to be rolling a die. This is an independent event from, choosing those. So that means now this is going to be probability. And now as you're going to be rolling it, it is equal or less than 5. So it is equal or less than 5. That's what we want to see on the die. So first, what is the probability of selecting somebody? Now, if there's 15% probability of someone liking the actual study of probability, that means there's 85% or 0.85. Make sure you change it back into decimal or fraction. Okay, of selecting someone that doesn't like probability, right? This is just simply 1 minus 0.15. Now, probability of rolling the die now. So now, what are the possibilities? So you're either going to get 5, and then or a 4, or a 3, or a 2, or a 1. So you have a pretty high chance of doing that, which is 5 over 6. And now all you do is you just multiply the 2 probabilities. So whatever that may be, let's actually this time around, let's multiply them. So this times 5 divided by 6. All right, so this is approximately 70.83%. If you're going to do that. That would be this particular question. All right, question 13. You have 20 red marbles, 30 green marbles, 50 blue marbles. So in total, it looks like we have 100. What is the probability that you draw a red marble, then a green marble, then a blue marble? Assume no replacement. So again, this is conditional probabilities. So here, first, for question number 13, so what do we have? First, we want to see and draw a red marble. So what's the probability of drawing a red marble? Well, if there is 100 marbles in total, there's only 20 of them that are red. So that is the probability on your first go. Now, you're going to be multiplying it. Now, you have taken out and you're assuming that you have lost 1 red marble. All right, now you want to see if there is a green marble. So how many green marbles are there left? There's 30 green marbles, but there's only 99 marbles left in total because you took away one of the red ones. Then next, okay, so you're going to multiply again, okay, because you're taking out and you're drawing and seeing if you're going to get a blue marble. So now the blue marble, well, there's 50 blue marbles. Now you've took away 2 of those marbles. So there you have it. So that's your probability. Now all you do is you multiply these out. You can convert them back into percent. So let's actually do it. Let's see what that gives us. So we have 20 times 30 times 50. So that's going to be 30,000 divided by 100 times 99 times 98. That's 970,200. So now we can divide the two. And we get approximately, so this is not a very big probability, so let's say it's approximately 3.1%, kind of rounded. That's it. That's your probability of actually doing this in order, and we're assuming no replacement. All right, next one. Okay, so question 14. You have 20 red marbles, okay, 30 green ones and 50 blue ones again. What would be the probability that you would draw 5 marbles and none of them would be green? None of them would be green. So this one right away rings a bell in terms of using conditional probabilities. So none are green. None are green. So what's the probability of that? So now we're drawing 5 marbles. 1, 2, 3, 4, 5. And none of them are green. Right? So if none of them are green, then what you're trying to see is, okay, so what's the probability of first drawing a marble and then not seeing a green one at all? Well, so how many green ones were there? There's 30 green ones. So that means now we're going to assume no replacement. All right, so let's assume that for this one. So on the first one, so how would we do this? So this is your first draw. So first you have a 70 out of a 100% chance of not drawing a green marble. Okay, on the second one, you have now, okay, so with this, because you have removed one of the marbles, all right, so now you have a 69 out of 99%, okay, or sorry, out of 99 marbles. Now, why is that? Well, you took out on the first one of the marbles that wasn't green, right? And you have basically a 70% chance on that. So once you take one out, so now you have one less. That could have been a red or it could have been a blue. So now that's on the second one, so you have one less, okay, and then one less. Now we're going to be multiplying this, and as you can see, now it's going to be 68 over 98. And then you're going to see 67 over 97. And then finally, you're going to see 66 over 96. So those are your probabilities. So you're basically on each single time, what is the probability of not drawing a green marble? Okay, so here, this would have been the probability. Now we go ahead and we multiply the numerators by the denominators and we get our answer, whatever answer that might be. So that's how you do question number 14, which is what would be the probability that you would draw 5 marbles and none of them would be green? Well, that's the probability. None of them are green. Okay, last one. You have, again, the same type of marbles. What is the probability that you draw 3 marbles and at least one of them is red? One of them is red. All right, and I'm going to assume again that there is no replacement. All right, so at least one of them. Now this is 3 marbles. All right, at least one is red. Okay, so 1 is red. Well, so this actually will be complements. So 1 minus the probability, all right, of no red at all. So using the complement, so 1 minus probability of nothing is red, right? So just as we did in the previous example, so if we have on the first draw, okay, marbles, and they're not red. Now let me go back here. So red is, so there's 20. So that means we have an 80% out of, 80 out of 100% out of 100 chance on the first one of drawing not a red one. Okay, then we would have, so there's one less, 79 out of 99. Okay, so that's that because we drew one away. And then finally we have 78 out of 98. And that would be the probability, okay, that there is no red marbles at all. So if we take the complement of that, that means that at least one of them must be. So either 1, 2, or 3. Okay, those would be the probabilities. So what you would do is you would have to multiply these out. You would substitute it back in, and you say 1 minus the probability of no red at all, and then you can get your answer. All right, so let's do this one to finalize it. So that's the probability of that, and now we want to take 1 minus this. So if we do that, so our answer, okay, so you're going to take 1 minus that, so it's not going to be the negative, so it's going to be around 49.2%. So this is going to be around 49.2%. That's what you would get of at least one red one. And that completes these 15 examples. I hope that this gives you more idea on how to approach these types of probability questions. Thanks for watching. See you in a future video. Bye, everybody.